Okay, so now we know how to add or subtract fractions that have the same denominator. What if they have a different denominator? Now remember the way that we convinced ourselves that 2/3 plus 5/3 was 7/3. We understood that in pretty much the same way we would understand 2 inches plus 5 inches equals 7 inches. The thirds just tell us what the things are that we're adding together. Right. Now, that's important because let's say someone told you, I am 5 feet and 7 inches tall. Right? You would certainly not add together 5 and 7 and say, oh, so you're 12 feet tall, or, oh, so you're 12 inches tall. That's certainly not the case, right? 5 feet and 7 inches are, in this way of understanding, like fractions with different denominators. We're comparing different kinds of things, so adding them is difficult. But let's take a look at some number lines and see what happens. Let's draw number lines and look at the vectors for 1/2 plus 2/3. On this first number line, I'm going to divide each unit into 2 equal parts and use this first number line to draw 1/2. So here each of my units is divided into 2 equal parts. I'm just going to take one of these, and that's 1/2. Now on my next number line, I'm going to split each unit into 3 equal parts. And notice I've carefully drawn these number lines so that their units are the same size, so that I can actually compare them against each other. With my units divided into 3 equal parts, I'm going to take 2 pieces like that, and that's going to be my 2/3. Now I'm going to draw a third number line, and I'm going to use it to try to figure out what my sum is. So first I'm going to make a copy of my 1/2, and I'm going to move it down so that it starts at 0 on the new number line. Next I'm going to make a copy of my 2/3, and I'm going to move it down so that it starts where 1/2 ends on the new number line. So I don't know what number it is, but I know that my result vector is the vector that starts from 0 and ends where 2/3 ends. So what is that? Well, first of all, if I pick this up and I move it up by my first number line, I see that this does not correspond to any of the half marks. My result is not a number of halves. Similarly, if I move this over by my second number line, I see that it doesn't correspond to any of my third marks. My result is not a number of thirds. Maybe I might think, well, I'm adding, right? 2 plus 3 is 5. What happens if I split my units into 5 equal parts? That doesn't quite do it either. My result is not a number of fifths either. Here's what we end up doing. We don't add fractions with different denominators. Instead, we come up with equivalents that have the same denominator. So in this case, here, I'm making marks on the first number line that correspond to each of my thirds, and on the second number line that correspond to my halves. And now after staring at this for a little while, I see that if I put in these tick marks as well, I'll have my unit divided into 6 equal parts. I'll see that 1/2 is equal to 3/6 and 2/3 is equal to 4/6. So I expect my result to be in sixths. On my bottom number line here, I'm going to divide my units not into 5 equal parts, but into 6 equal parts. And then I see that my result vector here corresponds to, counting them out, 7 of these sixths. 1/2 plus 2/3 is 7/6, which the normal way we would find this is by adding 3/6, which is equal to 1/2, plus 4/6, which is equal to 2/3. We do not add fractions with different denominators. Instead, first we rewrite them as equivalents that have the same denominator, and once we've done that, we add the like fractions that we have now. And of course, since subtraction is really addition in a funny hat, anything we say about addition also applies to subtraction. Let's see one more example without the picture this time. Let's subtract 11/12 minus 7/18. So our first move is to rewrite them with the same denominator. By the way, do you see the way I've set this up for rewriting with a common denominator? I really recommend that you set up your rewriting in this way. It's just so much easier to keep track of what you're doing at every step. So now we're finding out what the common denominator is. We turn to the calculator. We could do this by hand as well. We go to Math, go over to Num, and scroll down until we find LCM. We want to find the LCM of 12 and 18. We see that it's 36. Now, I happen to know that 12 times 3 is 36, and that 18 times 2 is 36. If you don't happen to know those off the top of your head, you are welcome to use the calculator to do that division. I multiplied the denominator by 3. I have to multiply the numerator by 3. 11 times 3 is 33. Here I multiplied the denominator by 2. I have to multiply the numerator by 2. 7 times 2 is 14. So our subtraction problem becomes, instead of 11/12, we're going to write 33/36. Instead of 7/18, we're going to write 14/36. Our result, the denominator will still be 36, and the numerator will be 33 minus 14, which, again, you can use the calculator for this arithmetic if you'd like, but it's 19/36. Now notice I did not tell you to simplify your answer, so it really shouldn't matter to you whether or not this result is in lowest terms. It happens that this result is in lowest terms, so there's nothing to simplify even if you wanted to. But unless we have some reason to simplify our answer, we can just leave it like that anyway.